We will create modified dictionaries, including the sets, at the end of the next week, using the proper syntax. We need to know how we can access or iterate through the dictionary by its keys, values, or the items. We will apply common dictionary and set methods to solve some problems. Then we'll see how we can differentiate between, not between, among lists, tuples, dictionaries, and the sets, and how we can use the sets and dictionaries in our real world data processing task. So dictionary. What does mean by dictionary? Have you used dictionary before? Which dictionary have you used?
General one, like we use solid line.
So which one?
Like no one knowing use solid line.
Yeah. So what's the name?
Like
an Oxford dictionary, right? English to English. So what's in there? The word and the meaning, right? And mostly words are unique. If there are like multiple meanings of a word, you can see like word and their meanings. But you cannot see multiple words as a key, right? That means one unique thing is like the keys are unique, the words are unique. We don't have multiple words, like not the same word we're using in different places to have their meanings. So we're using the same strategy here in the dictionary. We have a key and value pair. So far in the list, tuples, and the strings, we have just a sequential iteration, or we're storing the data in a sequential fashion. For example, like a string, there's sequence of characters. For a list, there's sequence of items. It could be any type, homogeneous data or heterogeneous data. The tuples are the same as the list, but the only difference is they are immutable. Now, this time in the dictionary, we'll see they're like a pair, a key value pair, not a single item, a pair of items. And here the pair is key and value. Just like our dictionary, the word and the meaning, here we have the key and the value. We may have multiple values, it's okay, but we don't have the multiple keys with the same name or same key. Okay. Okay, so the first thing is like how we can declare a dictionary. So far we have created list and tuples. So Python mostly work with the brackets. So for a list, we have used square bracket. For a tuple, we have used parentheses. For a dictionary, what left is like this curly braces, right? The curly brackets. So we can use the curly brackets here to declare a dictionary. So dictionary, this is like an empty dictionary. If you print the type of that particular data structure, you will see it is a dictionary. It is a class of dictionary. So dictionary can be used at dict. So DICT is a short name of the dictionary. Okay, this is the one way. The other way to declare a dictionary is the function, dict function. So if I'm writing D2 and print the type of the D2, it is also a dictionary. So this is like an empty dictionary, right? Now what's in there? Let me write the list. Here's our list, 1, 2, 3, 4. Here's our tuple, 1, 2, 3, 4, right? Is it right for the tuple? Is it the right syntax? Yes or no? Anyone saying no? Okay, it's a good thing that you observed the tuple. So you can write a parenthesis, but it's like a So you don't need to like write the parenthesis every time. If you're not writing any parentheses, by default, it is the tuple with the comma separated things. Now for the dictionary, the same thing. Here's our dictionary. I have 1 item, 2 items, 3 items, and 4 items. They are comma separated. But as I told you, in the dictionary, they are not single item. It's a key value pair. So if I'm saying this is a value, then I have to have a key. What is the key? Well, maybe the ID. What is the ID? 1, 2, 3. Now, how I can separate key with a value? With a colon sign. With the colon sign, before the colon, it is the key, and after the colon, it is the value. But what could be in the key? So right now I'm just writing ID. It should be string. Otherwise, ID cannot be found here. It's because ID is not defined yet. So what can be in the key? So let me write something here like ID, the name, and the grade. Grade can be whatever. And I can write here like some number or the age. So these are 4 items in the dictionary. As you see here, each item contains a key with its associate value. Now, what if I write here like multiple IDs? As I told you, in a dictionary, our regular dictionary, we don't have multiple keys. We may have multiple values, but we don't have multiple keys. So in the dictionary property, we are not allowed to write the same key in different places. We have to have one single key, like unique key. We cannot write here. If you write these things, then probably you have an error. So name, let me print the dictionary. Let's see what it prints. It prints like this way. Okay, key value pair. Now, when we have used list and tuples or string, how we have accessed the items?
Square brackets.
Square bracket. And what's inside this square bracket?
The index.
The index, right? That means they are ordered. 1, like 2 comes after 1. 3 comes after 2. That means they are ordered. As I told you, in the memory location, if you just, if I just write a diagram for our memory location. So here is the computer memory. I am defining a list 1, 2, 3. Maybe 1 starting from here, then 2, then 3. So they are in a sequence. They are not writing in this way, like 1 here, then 2 there, and 3 here. Not like that. They should be in a sequence for list, for tuples, and for strings. That's why we're calling it, it's a sequence. Sequence of character for the string, sequence of item for a list and tuples. Now, what happened here in the dictionary? Are they in a sequential fashion? You never know. There are basically 2 ways to write the dictionary. One is ordered dictionary, and there is unordered dictionary. So by default, it is an unordered dictionary. That means we cannot access by its index. That means if I access this item as 1, I'm not sure whether in the number 2 location it is grade or name. Though we're saying they are in a sequential way, but they are not actually in the memory. That means we cannot access it through its index. Now, what's the other way? The only one left is like, well, I know the keys are unique. I can access them by their keys. What are the keys? The ID. If I just access with the ID, it will print the value of that particular ID. Okay. Now the question is, what can be in that key? Well, in the dictionary, basically they are using the hash function. They are creating the hash of the key and then store the value with the hash so that it's easier to look at. It's easier to find that item. So for example, if I have like 1 million item and number 4 is the 1 millionth item, how I can access the 1 millionth item? Starting from 1, right? Just like this. I cannot access directly 3 here. I need to access from 1, then 2, then 3. Even if I'm creating an index. So for example, I'm writing L1, 3. It will start from L1. Where's the L1? Here's the L1. Where's the index? 3. Okay, plus 3. It will go there. This is the way the computer or the program find that item by its index. In case of tuple, in case of list, in case of string. But in case of a dictionary, it doesn't look this way. How it works? It creates the hash of that particular key. So for example, the hash of ID could be like 1, 2, 3, 4, 5, 6. Maybe this is the hash value of ID. Now, what is the 1, 2, 3, 4, 5, 6? It could be here. So I'm putting here the ID 1, 2, 3. Then the second item is the name. What is the hash value of name? Maybe 1, 2, 3, 4, 8, 6. Maybe this is the hash value of 1, 2, 3, 4, 8, 6. I'm putting here the name, John. The third item, grade. Maybe the hash value of grade is like 1, 2, 3, 4, 5, 9. Maybe here. So the name grade is like 94.5. You see here, we're not using the key. Rather, we're creating a hash of the key and hash actually mapping the exact memory location. Now, when I'm checking what is the grade of that particular dictionary, well, what is the hash of the grade? Hash of the grade is 1, 2, 3, 5, 9. You just look here. I don't need to worry about what are the other values are here. But in case of a list, in case of a tuple, I need to start from the beginning, then add by the index. But here we don't need to. That's why it is faster than list or any other data structure. Since we're not iterating one after another, we're just jumping to that location and find the value. Even if there are like 1 million items in a dictionary, I'm looking for the maybe 1 million minus fifth one. It will just get the hash value and go directly to that location. It never iterate through the dictionary. That's the beauty of using a dictionary. Does that make sense? Okay. So dictionary, as I told you, it is like a mapping, a key value mapping. And just like a list, we're using just the index, same as tuple, same as string. But here in the dictionary, we're using a key. But the dictionary is a key value mapping. So we have a key and its associated value. I already have told you about the dictionary creation. This is like dictionary initialization with some values, or you can create a dictionary using the dict function. But the good thing is the dictionary is mutable. That means you can easily alter it. But in case of a tuple, we cannot alter it. Whenever we're creating a tuple by initializing some value, it is done. We cannot modify it unless we are converting it to a list or some other temporary data structure. But in a dictionary, whatever we're creating from the initialization, we can easily alter it. But we cannot use the same key with different values. So let me write something here, like I am creating a dictionary this, and now I would like to create another item, maybe the department. I'm just writing, well, department is CS. Now my dictionary is this, department is CS. Now what if I use this one again? Will I have an error? As I told you, you cannot use the same key, like same value as a key. Yes.
Does it replace the value that was associated with that?
Exactly. It will replace. So what it does, it will look for this value. If it is there, then it will update it. For the previous one is look for that particular key. If it is not there, it will create with the value. That means it will update the value 1 to 4. Still, we are maintaining this property. The key is unique. ID is unique. We don't have multiple IDs. Now, if you'd like to add multiple grades, for example, here, what do you need to do? I may have multiple grades. I may have one ID, but I have multiple grades. For one course, I got 94.5. For another course, I have like 96. How do I do that? How do I add it?
I think you could have like a different key for each grade, but you might also want to make grade a list.
That means grade for 1400 and grade for 1410, like that, right?
Yeah, but if there's enough of those, you might want.
But in case of like 100 grades, it will create 100 items. What's the other option you told?
A list.
A list. So what you can do, we can create a list here, like grades, but it is the list. And our first item was like 94.5 or AMP, whatever it is. Now, how I can add an item to the list? If I use like D1
You want grades.
grades 96, what will happen?
It'll overwrite the list within.
It will override the list, but my plan is to add an item to that list, right? How can I do that?
Append.
Dot append. Yeah, it's the list. And I'm going to append this one. Not sure if it's the right syntax. It is. Good job. You.
Okay.
So this is the naive way, but there are some other ways. I'll show you how you can add an item to a list of dictionaries. But like, those are some built-in function. But right now we're working with naive way, how we can create multiple items in a key. So we have only one key, but in that key we may have multiple items. Well, you know, if we have multiple items, we can use the collection. What is the collection? A list, a tuple, right? So it can be tuple. But in that case, we cannot modify a tuple. That means you cannot append this 96 to that tuple. That means it's better to use a list. Or if you're using a tuple, you need to convert it back to the list and then append it. Make sense? Now, the second question is, what can be a dictionary key? A dictionary key can be a mutable item. Sorry, an immutable item. That means you cannot use a list as a key, but you can use a string as a key. You can use some number as a key, integer, float. Those are hashable. That means we can use a tuple as a key as well, since they are hashable. Let's see. So tuple as a key, and then the value for that tuple. This is a nice feature of dictionary, that you can use the tuple as a dictionary key. You can solve a variety of problem using this property. I'll show you at the end of this module, like in an interview problem, how you can solve a bigger problem using a tuple as a dictionary key. But keep in mind, you can use a tuple as a dictionary key, a string differently, and some other immutable items. Okay? Any question at this point? No? Okay. So dictionary operations. I already have told you how you can access a dictionary by its key. Well, there is an important feature, or the important things to know, that if the key doesn't exist, right now, I don't have the ID. And as you see here, the ID and ID are two different things. They are case sensitive. If you're just writing here like ID and accessing by ID, they are case sensitive. What if we don't have a key in the dictionary? What did you return? None? Error?
I want to say error.
Let me print it. It will raise a specific type of error, key error. That means whenever you find something like that key error, definitely that key doesn't exist. And like there is an easier way to resolve this type of problem. Like so far we have handled different types of error. So how we can handle this type of error? What are the ways to handle the errors? The first one,
Try and accept.
try and accept. Second one, oops. Third one,
If else.
conditionals, right? The three ways. First, start with the try and accept. So you will use the try and accept. As I told you, you need to write the specific type of error here so that you can handle multiple types of errors. The key error, if there's a key error, print key doesn't exist.
What's the problem? And C and E and accept is swapped.
This is the way you can handle the error so far we have learned. But there are some built-in dictionary methods that you can resolve this problem. So instead of just printing D1 ID, you can print this way. I would like to get the ID. This is another way to access the dictionary items by its key. Get will give you the same thing. But the good thing of using get is if the key doesn't exist, it will not raise an error. Instead, it returns a none. That means you don't need to use the try and except for the key error here. You can easily use the .get method. Sometimes you can handle something like, well, none type. Your program cannot handle a none type. So in that case, you can specify here like, well, if the key doesn't exist, I'm returning -1. So you can specify the return type. So by default, it is none. You can specify it here like -1. So now if the key doesn't exist, it will return -1 instead of none. This is the way you can handle different types of data other than none. Sometimes you cannot add some number with none, or maybe you can just using a 0 here. You're looking for some grade. If the grade doesn't exist, by default, it will return none. And what you're going to do here, you are just adding your grades. You're adding grades. And every time you are, here's our grade. And you are adding grades plus grade. In that case, if you're not writing 0, probably it will return a none. You cannot add 0 plus none. So to avoid this type of situation, you can specify specific type of return type, for example, 0. If the grade is not there, I can add 0. This is the beauty of using a get method to avoid the key error, to use different types of data other than none or none. Okay, that's what I mentioned here. Then I already told you adding and updating item. So adding is just like for D1, I would like to add an item, for an example, UView ID. And updating is like if the UView ID is already there, then it will update that value. For example, the ID is there. If I'm just changing the ID, it will not create an ID. It will update the original ID. And this is the way you can add an item. So this is the same expression. The first one will add, second one will update. That's because the key is already there. If the key is not there, it will create. Okay, now removing an item. So there are various ways to remove an item from a dictionary. One way is like using a del keyword. Probably you have used del keyword before, right? For a list, for a tuple. So del keyword can also be used here. So del dictionary ID. This is different than del D1. What's the difference? One versus the whole, right? Keep in mind, whenever you're deleting these things, you need to make sure you're writing those things. That's why whenever trying to delete from any web server, they are asking you another confirmation. Are you still deleting this item? When you say yes, then it will delete, like a second layer of confirmation. So yeah, whenever you're using these type of things, make sure it's a second layer of confirmation. But we're not working here in this class. So this is the first way, deleting an item. What if the ID is already deleted or ID is not there? It will skip or raise an error. If that is not there, it is trying to delete, but it is not there. That means I don't need to worry about it, but at least some error. Key is not there. Okay. Now, there are various ways to delete an item. One way is like the .pop method. dot pop method will remove an item by its key. And then another method is like pop item. Do you remember pop versus remove in the list method? What's the difference between pop and remove in a list method? Anyone? Both are deleting, but what's the difference?
What gives you the item you're removing?
Pop delete what?
It gives you back the item you're removing.
Okay,
Use it elsewhere.
and what is the other difference?
Defaults the last item.
Yeah, before the last item. Yeah, so the pop actually deleting the last item and remove actually giving you the catch. So pop actually removing the last item, but the good thing is like it is giving you like returning you the value as well, what it is removing. And remove is like you're removing something, that's it. So here in the dictionary, pop will remove an item by its key, and the pop item remove the last item. You never know which is the last one. It's because they are not ordered. It means if you're using pop item, make sure you know what is the last item. So that's why it is better to use the pop method, which will return the value as well, what it removed. So it removes the ID and gives you the value as well, that, well, I have removed this ID. But the pop item will remove the last item, but I don't know which one is the last item. It will give you the tuple of that item. You can see a tuple, key value tuple in a packed way. If I'm just writing multiple pop item, first one remove the age, second one it removes the grade. Okay. Now, one important thing is like clearing a dictionary. What is the difference between deleting a dictionary and clearing a dictionary? Right?
One will completely remove it and the other one will keep the name of the dictionary.
Like this?
Yeah.
So you have the roll, but there's no tissue there. And deleting is like, there's nothing here, nothing here. And identify is like, there's no holder there. Okay. Hey. Job. I'm bad at throwing. So clearing is like actually keeping the dictionary, but removing the item. So even if you're printing the dictionary, it will not raise any error, but just empty. But instead, if you're just writing del D1, then probably you have an error. It's because you're just removing the holder. Does that make sense? So which one is the safer? Clear, basically, right? But depending on the scenario or situation, sometimes this particular dictionary holding some space, if there are like 1 million dictionary you are clearing up, so each of the dictionary is holding empty location. Still, you have 1 million dictionary with empty items. In that particular case, deleting is the best way. Does that make sense? Okay. Now, checking the keys or iterating the dictionary, how I can iterate a dictionary. Like a list, how we have iterated. The first way, right? The second way is index in the range of length of L1. This is the second way. What's the third way? I just have mentioned in the last class. It is easier. That will just merge. Oh my God. Okay. The third way is enumerate, right? It will just merge those two things. So if you're using enumerate L1, it will give you ID and index, the index and the value, right? In a packed way, unless you are specifying here some other numbers other than 0. If it is a 0, then it is fine. If it is not 0, then basically it's not the index. It's something else. Now, how I can iterate a dictionary? It's indexed. It doesn't have any index. Then enumerate. Enumerate will give you index and item. Still, we don't have the index. The item is the whole thing. So if you're just writing here like a D1, it will give you the item as a tupled way. Oh, it gives you the keys. I was expecting it should be a tupled value. It takes the value as a key. Well, now we are getting the keys. How we can access key, like the value from the key? Just print the dictionary with its key. By its key. You have the ID and key, and for that particular key, we have the value. Same thing, ID and the key, for that particular key, you have the value. ID and key, for that particular key, you have the value, so on and so forth. But I don't need the index. But here, I'm just taking index as a byproduct from enumerate function. So what do you think? What it will return from each item? A tupled up key value or just the key? What's in the item? A key value pair or just the key?
I think each line. So it'd be the ID and 1, 2.
That means key value pair, right? But unfortunately, or the good thing of the Python is like whenever the dictionary is like whenever you are iterating a dictionary, it is iterating through its key. So you have the keys only here, not the key value pair. Okay, but there are some functions, actually methods for the dictionary where you can get the keys and the values. The function name is dot keys. Dot keys will give you the list of keys. The list of keys. But you can see here it's a different data structure. We don't know what is the type of the data structure, so it's better to convert to a list. But since it is a sequence, that's why we can use a for loop to iterate over the sequence. But if you just convert it to a list, we have a known data structure. The same thing, it has a function called like values. The values will give you the values only, not the keys. But the problem is value can be duplicated. The ID cannot be. Like I can use your name as 1, 2, 3. Just like Elon Musk sound, right? It is the number on the name. The probably name is the 1, 2, 3. Now I have multiple 1, 2, 3. I don't know which one is for the name, which one is for the ID. That means it is not a wise decision to use a values function to iterate. Like you cannot get the keys from the values. Like if you're trying to iterate from here, dot values, how can you get the keys from the values? We cannot. It's because values can be duplicated, but keys are not. So you cannot go reverse way. From the value, you cannot go back to the key. But from the key, you can get the value. So that's why it is better to use the keys instead of values. And as I told you, the keys function is redundant here. The dot keys and D1 will give you the same thing. If you just print here dot keys, it will give you the keys with iterated way. And if you're not using the keys function, it will give you the same thing. So in that particular case, the dot keys function writing is extra things. You don't write it here. Now there is another function called like items. The items will give you key value pair in a tupled way. Now, let me see what's inside the items function. Like what it returns. It returns items where key and value are in a tupled way, packed way. And what it is actually? List of tuples, right? In a packed way. That means if I print the items here, it will print the key value pair. Now, this is a tuple, basically. That's why you are getting a tuple. But how I can unpack a tuple? I can unpack a tuple here, right there. Key and value. Now, instead of item, I can just print the key and its associated value. Okay. So you could either use dot keys or D1, which will give you the key only. From the key, you need to get the value. That means you need to call it every time. But if you're just using the items, you have the key and value in a packed way, then you can unpack it and get the key and value. This is the best choice whenever you are iterating a dictionary. You have both the keys and values. Like you have the values, the same value, you have a duplicated value, but you need to find out the key. You cannot find a key from a value. The reverse is not possible. That's why if you have an association key value pair, you can easily see it like, well, here's the key, here's its value. I have two same value like 1, 2, 3, but one for ID, one for name. Does that make sense? Okay. You can also check whether the key is not there. So whenever we are printing, or maybe here's my function like add function, add grades. I'm passing the whole dictionary and I would like to grace your grade. That's why I would like to find out the grade. I need to find out the grade. So D1 grade. And then I would like to grade you by 10 points. And here's your updated grades. I'll just update your grade by, actually it will update here. Eventually it will update here, so we don't write it again, but I can write in naive way, like current grade is this, then updated grade is that, current grade plus 10. Then I'm going to update your grade by the updated grade. Right? Now I can rewrite these 3 lines in just this way. It will take the grade, update the grade, and update it to the dictionary all together. Okay. Now the question is, I don't have the exact key here in the grade. That means I'll have a key error. So you are claiming like you told me to grade 10 points, but my grade is not updated. That's the reason. I put a wrong grade. Small g and capital G makes a difference of 10 points. Now, the one way is like you can use dot get. So dot get. If it is not there, then you have an error here. This will return a none. So I can put here like 0. And probably your grade was 85, you're expecting 95, instead you're getting 10 only. That's the reason. From the get method, I don't get your grade, but 0, then 0 plus 10 and update it to 10. How can I solve it? If I'm not using, well, for the previous line, you will have an error. For the previous one, we have an error as because the grades doesn't exist. So the first thing of checking those type of things is like checking whether the key is there. If it is there, work with it. If it is not there, then do other things. So how we can check whether the key is there? I can check a conditional. The second way of handling the errors, right? The first way is like try and accept. The second way is checking with the conditional. So I'll check whether the grades in the dictionary, if it is there, then I'll change it. If it is not there, then probably I'll do other things. Give you 100 points. That's what it gives. So if you have like 75 points in the smaller grade, adding by 10 is 85, but unfortunately or fortunately, you're getting 100 with my error. At least we're checking. There is no error. So this is the same as dot keys. It is redundant. Dot keys and D1 will give you the same thing. It is an iterator. I'm checking that particular item to that iterator. Okay. So you can use an in operator to check whether the key is there. How you can check whether this value is there? Well, value can be duplicated, but still we can check whether the value is there. With the values will give you a list of values, and I'll check whether this particular value 1, 2, 3 is there. I don't know whether it's the name or the number, like name or the ID, but it is there. Okay. Hashing. I told you about if anything is hashable, only we can use that item as the key for the dictionary. You already have learned the hashing things. So 100 can be used, 9.81 can be used, Python can be used, a tuple can be used, but not a list. It's because list cannot, like list is not hashable. we cannot use a list as a key of a dictionary, but tuple can be. Okay. Using a list as a key. So there has been error. So here's my dictionary as a list. I'm just creating a list as a key, but we'll have an error key error. Same thing for a dictionary as a key. I have a dictionary here. I'm putting this dictionary as a key. Still we have an error. Dictionary cannot be used as a key. It's because the same way, the reason. Dictionary is not hashable. Dictionary is not immutable. That means it is mutable. If anything is mutable, you cannot use it. Dictionary is mutable, list is mutable, some other data structure can be mutable that we cannot use. But if anything is not mutable, like immutable, only then we can use it. Like a string, some other data structure, like data type, and then the tuple. Okay. Okay, in operator, I already told you. I already told you about the collection of counter, like you can see here. Instead of these, I can use in that particular case, it can be used as a counter. Counter means like I'm getting the value and updating it and updating the dictionary altogether. So three things is done here. First, I'm getting the value of D1 grades, then update that value by 10, then update that particular item to the dictionary. So three things that happened here. Okay. Iterating, I already have covered this one as well. You can iterate by the key, by the value, or dot keys will give you the same thing, but is not required all the time. Over this one and this one will give you the same thing. This is the redundant. The values, and I told you about the key value pair, the item will give you the key value pair in a tupled way. Okay. One important thing is like so here's my dictionary. And what I'm going to do here, I will delete the key one at a time. Or I'll just delete one single key. Whenever, if the name is there, name in the D1, just delete that name. Can I do that? Well, typically in a list, we can do that. The name is like key. If the key is a name, typically delete can be occurred anywhere, just like a list. When we're iterating a list, we can easily delete an item, right? We can add an item, delete an item. Same thing for the dictionary. Whenever we're iterating, we can delete an item. But in the dictionary, we cannot. This is the property of dictionary. We cannot shrink it when we're iterating it. We cannot modify the whole dictionary. We can modify the values, but we cannot change the item. So for an example, this one, if you're just deleting this, it is not possible. But with some condition, we can do that. Like this is possible. This is possible. But if you're just deleting the name, then it is not possible. When we're iterating an item, we cannot delete that item. Okay. Sorting. Well, As I told you, the dictionary is not an ordered way. We can sort it by its key or by its value, depending on our scenario. So if you're just writing sorted dictionary D1, I will sort by key, by value, by both, or none, nothing. What do you think? If I just print the D1 with sort or not, or if it is sorting by key, by value, well, by default, whenever you are iterating a dictionary, it gets the keys. That means by default, it will sort by the keys. If you need to sort by its keys, again, this is redundant. Dot keys or the dictionary is the same. But if you're going to sort by the values, then to sort by the value. You can see here dot values will give you the values only. You're not getting the full dictionary. Basically sorted, return a list of whatever you're putting it there. So you're putting it here, a sequence of values. Maybe unsorted, you're sorting it. But you're not getting the key and value pair. And again, if you have the multiple item 1, 2, 3, 1, 2, 3, how do you know whether it's the ID or name? It is not an easier way to solve a sorting problem in a dictionary when you are using a values. It's because you have multiple values, like same values for multiple keys. So it's better to use the keys. So if you have a keys sorted, you have a list of sorted keys, then you can create a new dictionary with a sorted one, sorted by whatever it is. So here's some examples. This is our student versus student. Students are here. Name, major, year, GPA. If you'd like to sort by the key, it will sort by the key. You can sort by the value by just tweaking it here. Item, then for the item, you're sorting by the second, like a tuple sorting. Items will give you a tuple of key value pair, and you know how to use the tuples second item or third item sorting by the key. In the key, I have written a function. Function will give you the second item all the time. That means this item will have a list of tuples. You're sorting the list of tuples by the second item. That means by the number. Then you are creating a new dictionary and you're iterating it. Question?
Are those like sort by functions unable to take parameters?
Sort by function. Which one?
You know, like the one you use for the key.
Mm-hmm.
Are those unable to take arguments?
Yes, as because you need to provide the header of the function, just the name.
Okay.
So you are not calling a function inside the key. If you're calling it to provide the parameter, right? What's the parameter here? Basically the student.items, right?
Yeah.
And then for the student.item, it will take one at a time. That means you need to iterate it again. So that's why that makes your life easier to write just the function name. Over that list of items or a collection of items, it will iterate one at a time to that function, and it will sort by the second item. By our definition, second item. If it is like a 0, then it will sort by the first item. But sort by first item will give you the same answer of this one. Like by default, it will sort by the first item. You don't need to write it here. If you need to sort by second, third, or some other numbers, then probably you need to use the keyword. Okay. Any question at this point? So let me check how much we have covered. So declaring a dictionary, I told you about those things. You can use either a curly bracket or a dict function, different values for the same keys. Then you have updating, you're actually updating it. Keys doesn't accept any space. Should be hashable or immutable items like a tuple, integer, string, etc. Hashing function takes the data and creates the integer value representing that data. How you can access it? You can access it by its key, but if the key doesn't exist, you'll have a key error. To avoid this type of situation, you can use the .get function. .get function will give you a none type by default, unless you are specifying some return type there. Adding and updating, same way of accessing. If the value is not there, if the key is not there, it will add it. If the key is already there, it will update the value. This is the deleting of dictionary, pop item. Pop will give you the particular ID values. It could be anywhere. Pop item is the last value that will be deleted, and it will give you a tuple of key and value. And both are returning the item. For the pop, it returns the key, value. For the pop item, it returns a tuple of key value. If the key doesn't exist, well, let's see. Probably an error. If we are going to pop an item, if it doesn't exist, we have an error. Same thing for the pop item. Pop item doesn't have anything. Pop item will give you the popped one, but what if I have an empty dictionary? Probably it will raise an error. Like the dictionary is empty, but you're trying to pop an item from there. Okay, list and dictionaries. The hashable things, list is not hashable, so you cannot use the hash. Accumulating a list. Let's see. Well, I told you about these things, like in the accumulation fashion, you don't need to use these like grades. You can just write this way so that it will take the value, update it, and update to the dictionary as well. Okay. What else? Dictionary methods. I think I already have covered most of the dictionary methods. Okay, I was here. Del versus pop. Del is deleting an item, but it will not return anything. But pop will eventually delete and give you the return value, just like our remove and pop function in a list. Checking the keys in operator. Keys should be unique, hashable. List cannot be as a key, but tuple can be. Checking the values in the in operator, but make sure you use the dot values function to get all of the values. Dictionary can be used as a counter. Iterating a dictionary, you can iterate through its keys. By default, it is the key. Or you can iterate the dictionary by its items, which has the key and value in a tuple pair. You need to unpack it with the key value, or you can just iterate it by its values. With the dot values function. As I told you, modifying while iterating, you should not change the size of the dictionary while iterating over it. Then how you can modify it? Probably with some conditionals. Like with this condition, you can modify it, but you cannot change the size of the dictionary while you're iterating the dictionary. For the sorted dictionary, you could either sort it by the key or by the value. As I told you, there might be multiple values, so you may not sort it, or you cannot get the key from that particular value. But if you're using a key to sort it, then you can easily find the values associated with the key, or you can use a dot items function to get the key value pair, and based on the sorted, it's a list of tuples. You can easily specify the key with some function so that it will sort by the first item, second item, or onward items. This is the easiest way. For the dictionary methods, I already have told you about the dot keys, dot values, and dot items. List will give you the list of whatever inside there. If it is a dictionary, it will give you the list of keys. So if you're putting dictionary inside a list, it will give you a list of keys. It's because by default, dictionary is a collection of IDs, like the keys, right? That means whenever you are converting it to a list, you have a list of key, not key value pair, just the keys. So keep in mind. So what I was talking actually this way. If you're just writing list with D1, it will not give you a list of items. It will give you a list of keys, just the keys. It is not the key value pair. But if you're just writing key dot items, then probably you have a list of tuples, while each tuple is an item. Okay. And the get like method is really important. If the key doesn't exist, you will have a key error. To avoid this type of error, you could use the get function, and you are not specifying the optional parameter. By default, it will return a none. Sometimes you may not use a none type value to process later. In that particular case, you can specify the return type. The set default, I'll discuss those things in next class actually. What is the set default and other things? Let me know if you have any question at this point.